Hello, my dear warriors. Welcome to the JEE 2024 PYQs solving session. And today we are going to solve all the PYQs from your January as well as the April attempt from the chapter of kinematics. And that includes both one dimension as well as two-dimensional kinematics. So let's begin with the class. And this is your Captain Shreyas, your physics master teacher, who has been training nurturing kids for more than 13 years. So now it's your time to get your mentorship done under my guidance on this Vedantu JEE English channel. So make sure that you are quickly subscribe to the channel and show your support for these kind of sessions by quickly smashing the like button down there. Thank you so much. I hope you have done that. So now it's time to solve questions after questions. Get ready for this session and show your support, or else you won't see more sessions like this. Okay? So thank you for liking and subscribing. So let's start with the MCQ questions first, and then we'll go to the numerical time. Okay, here's the first question. You can check this out. Options are given. Two cars are traveling towards each other with 20 meters per second. The distance between them is 300 meters. They apply brake and retard at 2 meters per second square. The distance between them when they come to rest. That is the question. So quickly, let's think about the diagram. If you take a particular car which is going with a speed of 20 meters per second. After traveling some distance, it will stop. Let's say that distance is x. Okay, so now if it has to stop, we can use v square is u square plus 2as, third kinematic equation. V square is u square plus 2as. Final velocity is 0. Initial velocity is 20. Acceleration is negative because you are going to retard at a rate of -2. Displacement is basically x. So 2 2s are 4. Bring it on the other side. It will just become 4x is 20 square, which is nothing but 400. Therefore, x is nothing but 100 meters. Now, the cars are coming towards each other. Keep that in mind. So, this car going like this will stop after 100 meters somewhere here. This car coming from here will again stop after 100 meters somewhere here. And the original separation between them was 300 meters. So when they finally stop, what is their separation going to be? 300 minus 100 minus 100. So it will be 300 minus 300 minus 100 minus 100, which is just going to make it 100 meters, which is option number B. That is the correct answer, right? So you just had to use the third kinematic equation. The situation is symmetric. Both the cars had the same speed, same retardation. That's why their stopping distances were also equal. And then subtracting the original distance with the braking distance, you get the final separation between them. I hope you guys got this answer. So here comes the next question on your screen. There is a particle going in a straight line covering half the distance with this speed, and the other half is covered in equal time intervals. 9 and 15 are the speeds respectively. What's the average speed for the entire motion? So let's start by drawing a diagram. So let's assume the initial half of the distance, which is x, is covered with a speed of 6 meters per second. Now the remaining half is divided into two equal intervals. So their distances could be quite different. Their distances could be quite different. It could be x1 and x2. But together, if you add x1 and x2, it will be still x only. If you add x1 and x2, this is the other half of that distance which was covered in equal intervals of time. This one was covered at the speed of 9 meters per second, and this one was covered at 15 meters per second. Now, if you ask me what is the average speed formula, what is the average speed formula? It is the total distance, which is nothing but x plus x1 plus x2. The whole thing divided by the total time. Let's say it will be t plus t1 plus t2. T is the time taken to go from here to here. T1 is the time to go from here to here, and T2 is the time taken to go from here to here. This is the total time. Now, out of these, do I know certain things? Out of these things, do I know certain things? The answer is yes. Like for example, x1 plus x2. So therefore, I can just write x1 plus x2 itself as x. The whole thing divided by this time. The time to go from here to here, will be distance by speed. Remember, speed is distance by time. So time is distance by speed. So I can just write it as x by that particular speed. Now to find this T1 plus T2, how do I do this calculation? Well, let's think about it. Well, T1 will be this x1 divided by this x1 divided by nothing but your speed, which is 9. This T2 will be this x2 divided by the speed, which is again 15. So from here, x1 is basically 9 T1 and x2 is basically 15 times of T2. If add both of them, what do I get? I basically get x. So x1 plus x2 we know is actually x. So x1 plus x2 means it will be 9t1 plus 15t2. So this x is nothing but 9t1 plus 15 times of t2. But hold on, I know that t1 and t2 both are equal. I just know t1 and t2 both are equal. So whether you put T1 or whether you put T2, it is one and the same thing. So 9 plus 15 is basically 24. So 24 T1 is basically X. So therefore, T1 is nothing but X divided by 24. T1 is nothing but X divided by 24. So instead of T1, I can just put over here, X divided by 24, and T2 is also the same. So it is again X divided by 24. So you can see X will get cancelled everywhere. So 1 plus 1 is basically 2. And here I have 1 by 6 plus 1 by 24 plus 1 by 24 will make it 2 by 24. 2 cancels with 24 becomes 12. Now you take the LCM. So 1 by 6 and 1 by 12, the LCM is 12. So it will become 2 plus 1 over here. So it will become 2. 12 goes on the top. 2 plus 1 is basically 3, goes with 4 times. So it will just become 8. So 8 is the answer, which is option number D, like you can see over there. I hope this is absolutely clear. It was just play with the variables. You had to manipulate it in such a way that all the assumed variables like x, x1, x2, t1, t2 eventually get cancelled out in this problem. Okay, moving on to the next question on your screen. What does it say? The angle of projection such that same range and same height will be how much? Okay, let's understand what it means. So this is the ground level and you throw a projectile at some angle, let's say theta, with some speed. It goes up and it falls down over here. We want that this particular height should be the same as this particular range. The height and the range should be equal. I think it is just the use of formulas and probably substituting the formulas. I think we should be able to get the answer. So the range formula we know is nothing but 2u square sine theta cos theta, the whole thing divided by g. If you talk about the height formula is nothing but u square sine square theta divided by 2g. As per the question, both of them are equal. Both of them are same. That's why I equated both of them. U square will get cancelled. Check this out. U square will get cancelled. G will get cancelled. Sine theta, one of it will get cancelled. So I am left with 2 times of cos theta is nothing but sine theta divided by 2. Take the 2 on the other side and bring the cos theta down. So it will become sine theta by cos theta. What is sine theta by cos theta? It is nothing but tan theta. So tan theta is 4. So theta will be nothing but tan inverse of the number 4, which is option number D, as you can see, which is option number D. I hope this is absolutely clear. Okay, direct substitution of formulas, nothing great apart from that. So you should be very well versed with the formulas. And if you're loving this session, I hope you have smashed the like button. In case you have forgotten, just a quick reminder. Moving on to the next question. There is a body which is thrown up certain speed from the top of a tower. It reaches the ground in T1. If it is thrown down, same point, same speed, it reaches a little bit quicker, obviously, if you throw it down with a different time, T2. If you just drop it, then how much is the time? Wow, what an interesting question. Let's try to analyze it. So, if you throw something upwards with some speed u, it will go up for some time before eventually coming down and hitting the ground level over here. Let's say the height from which it has been thrown is h. And if I take upward direction as standard positive, okay, upward direction as standard and positive, then using displacement is ut plus half at square. The displacement is negative h because I'm eventually coming down. This is final position. This was initial position. Remember that. U is positive, so ut minus, because acceleration is downwards, minus half gt1 square. This is what I get. Fair enough. Next, let's probably multiply it by -1 so that it looks little good. So h will be minus ut plus half gt1 square. That is what it looks like when I multiply it with -1. Next scenario, let me throw this down with the same speed and it comes down by a height of h before touching the ground over here. Now in this case, this is the initial position, this is the final location. Again, using displacement is ut plus half at square. Displacement is minus h. U is negative because it is coming down, minus because gravity is downwards, half gt square. Multiplying it with negative sign, h is nothing but ut plus half g, but this is t2, half g t2 square. This was t1 square. Now, even this time over here is actually T2 and even this time over here is actually T1. I can say UT1, I can say UT2. Maybe I want to get rid of them, maybe in the next step. Okay, let me go to another scenario. The third scenario is when you drop it. So when you drop it, when you just drop it, zero velocity, it falls down by height h before reaching the ground over here. If I use s is ut plus half at square, it will be minus h is 0 minus half g t square. Multiplying it with -1, h is nothing but half g t square. Somehow I need to get rid of ut, or basically u. Somehow I need to get rid of u. I have an idea. The idea is, how about multiplying this with T2, multiplying this with T1, because if I multiply this with T1, this will be U T2 T1. This, if I multiply it with T2, it will be U T1 T2. So I can cancel them if I add those two equations. So if I make it H into T2 is equal to minus U T1 T2 plus half g t1 square t2, and this one over here h t1 is equal to u t1 t2 again plus half g t2 square t1. Now just add both of them. What do I get? Check this out. I will get h common, or rather h t2 from this side, and from here I will get h T1, HT2 from here, HT1 from here. UT1 T2, UT1 T2 will get cancelled. And again, from here, on the right hand side, I will have half G T 1 square T2, half G T1 square T2. And from here, I will get half G T2 square T1. Perfect. So what is the next step now? I can take h common from here. So it will basically become T1 plus T2 is equal to half G common from here. Even T1, T2 can be taken common and I will get T1 plus T2. T1 plus T2, T1 plus T2 will cancel. So h will become half G T1 T2. Now just compare this with this. Compare this with this particular equation. A very interesting thing you will see. What will you see, guys? You will see that t square is equal to t1 t2. That means root of t1 t2 is basically t. So time is root of t1 t2, which is option number B. Yes, that is the correct answer. So I manipulated this because I knew that u can't be there in the final answer. So I got rid of u by multiplying with suitable numbers and then adding those equations. And I did not expect that this will happen, but the moment I got this, I knew that I had to compare these two. So I can quickly see t square is t1, t2. I hope this is absolutely clear. Brilliant question, isn't it? Here comes the next question. A train is starting from rest, accelerates uniformly till 80 for time t, then moves with constant speed for thrice the time, average speed for the entire duration. Acceleration is not even given to me, but maybe I don't need it. Maybe we can do it graphically. Maybe it will help us. Let's see if we can do it graphically, because I can find the total distance then. Okay, so this is velocity, this is basically time. So first let me mark t over here, and then 3 times of time will be somewhere over here. So it will be 4t technically, okay, because this interval is basically 3t, understand that. This interval is basically t, that is what is given in the question. So it accelerates till it reaches 80 kilometers per hour. So this is 80, and then it maintains that speed till here. Oh, so in order to find the average speed, I need the total distance. I know the total time. So to find the total distance, you just need to find the area under the graph. As simple as that. So that's all I'm going to do, guys. So we'll try to find what is the area of this graph. So the displacement is area of the trapezium, and the area of a trapezium is half into the height and the sum of the parallel sides. This one side is basically 3t, and this other side is having 4t, that is the sum of parallel sides into the height, which is basically 80. So that is just going to make it 80 by 2 is 40, and 3 plus 4 is 7. That's it. 40 into 70 is basically the displacement. But we have to find the average speed. So the average speed is displacement by your total time. So the displacement is 40 multiplied by 70. Whole thing divided by the total time is nothing but 4 times of t. 4 cancels, t cancels. What am I left with is basically 70. So option number A should be the correct one. Yes, that is the correct one. You just have to find the area under the curve, which is very simple to find. If you know the formula for area of a trapezium, it becomes very, very straightforward after this point. Cool. Moving on to the next question. A body travels 102.5 meters in the nth second and 115.0 meters in the n plus 2 second. What is the acceleration? This was asked. This is nth second formula. This is nothing but your nth second formula. What is the nth second formula? Well, the displacement in the nth second is u plus a by 2 into 2n minus 1. That's the formula. In the first case, 102.5, okay, u I don't know, plus acceleration, that's what we have to find, 2 into n minus 1. This is the first scenario. In the second scenario, what is given is 115 is u plus same a by 2, but instead of n, it is n plus 2. So it is n plus 2 minus 1. I think we can play around with this a little bit. It will be u plus a by 2. It will be 2n. 2 into 2, 4. 4 minus 1 is 3. So 2n plus 3. That is what I will get as 115. Now take this and subtract the 2. I think that will be the best thing to do over here. Take this and basically subtract. Subtract the 2. So what I'm trying to do over here is 115. I subtract it with 102.5. What is left on the right hand side? Let's check it out. U and U will get cancelled. The reason why I subtracted is because U will get cancelled. I want A. So A by 2 into 2n plus 3 and minus a by 2 into 2n minus 1. Okay, so what do we get? 115 minus 102.5 is nothing but 12.5 over here. A by 2 is basically common. 2n will cancel. 3 minus 1 is 3 plus 1 which is basically 4. So this will just become 25. 2 into 12.5 is 25 into a multiplied by 3 plus 1 is 4. So a will be 25 divided by 4, which is option number A, 6.25. Yes, that is the correct answer. Okay, so here in this question, initial speed was not 0. A lot of people might think 0 was initial speed. No, In fact, it was not given, but need not worry. I assumed it, but I saw that it got cancelled the moment I subtracted this equation with this equation. So you have to play around with the equations. That's what you can see. Cool. Everyone, let's move on to the next question on your screen. The coordinates of a particle are this and this. What is the motion going to be? Accelerated, straight line, non-uniformly accelerated, uniform motion along straight line, uniform motion along parabolic path. So here is what we can do. From this equation, if I take 2 on the other side, x minus 2 is 4 times of t. So t will be x minus 2 divided by 4. How about substituting it over here? So over here, if I substitute, y will be 3 into, instead of time, put x minus 2 divided by 4 plus 8 into x minus 2 divided by 4 whole square. Obviously, this is a quadratic equation in x. If it is a quadratic equation in x, it will be a curved line which is going to be a parabola, the path. Parabola. Yes, the path will be a parabola. So hence it can't be a straight line and it is going to be a uniform acceleration. So uniform acceleration with a parabolic path. Remember, whenever you get a quadratic equation of y in x, then the the motion is going to be an accelerated motion, so which is uniform, just like your trajectory equation. Your equation of projectile is also a quadratic equation, so it is definitely a uniformly accelerated motion. Next one. There are two trains moving parallel to each other, north and south. Velocity of B with respect to A and velocity of ground with respect to B. Okay, let's try to think about this. Train A is going along the north, okay, with 72 kilometers per hour. 72 multiplied with 5 by 18. What will you get? You will get 4 times, so it will be 20 meters per second. This is in the north direction. Train number B is going towards the south with what speed? Multiplied by 5 by 18. So it will be 6 into 5, 30. So 30 meters per second towards the south. Assuming north direction or y-axis as positive. The questions are as follows. What is the velocity of B with respect to A? Velocity of B with respect to A is velocity of B minus velocity of A. Velocity of B is negative 30. Velocity of A is plus 20. Upwards is positive, downwards is negative. So this will be minus 50. So that's velocity of B with respect to A. Another question is, what is the velocity of the ground with respect to B? So when I say VB, velocity of B, that answer is minus 30. But who's the frame of reference? It is nothing but the ground. So that is minus 30. But we all know that velocity of the ground with respect to B will be negative of VBG. V12 is negative V21. So whenever you change the frame of reference into observer, you have to put a minus sign. So this will be minus of this whole quantity, which is minus 30. Hence it will be 30 meters per second and minus 50, which is option B. Yes, that is the correct one. Cool, guys? Everybody till this point absolutely clear? Right? So let's move on to the next question coming up on your screen. Okay, let's move on. Okay, so what does it say? There is a particle which goes in a straight line. Variation of position as a function of time is given as follows. The velocity of the body when the acceleration becomes 0. Okay, it looks like a straightforward derivative question because x is given. To find the velocity, you take the derivative of x with respect to time, which means you have to take the derivative of this entire equation, t cube minus 6t square plus 20t plus 15. Therefore, velocity will be derivative of t cube is 3t square minus 6 into t square's derivative is 2t plus 20 into times derivative will be 1. Constant's derivative will be 0. So what do I get? Velocity as 3t square minus 12t plus 20. Next step, let me find acceleration, which is derivative of this velocity. So acceleration will be 3 into t square's derivative will be 2t minus 12 into t's derivative will be 1. Constant's derivative is 0. So therefore acceleration will be 6t minus 12. As per the question, the acceleration becomes 0. That means if acceleration has to be 0, 60t minus 12 will be 0. Rather 6t will be 12. Rather time will be 2 seconds. Now use that time over here to solve this part. So at 2 seconds, what will be the velocity? It will be 3 into 2 square minus 12 multiplied by 2 plus 20. 2 square is nothing but 4, right? So 4 into 3 is 12. 12 minus 24 plus 20. So that's going to be minus 12 plus 20, which is going to make it 8. So answer should be option C. That is the correct answer. Perfect. Okay. Straightforward question, guys, on derivatives, nothing great about it. Let's move on to the next question coming up on your screen. A body moves from rest with constant acceleration and displacement is S1 in the first P minus 1 seconds and S2 in the first P seconds. How much is S1 plus S2 in the total time? Okay. In the first P minus 1 second. So from T is equal to 0, it moves S1 distance in time is equal to P minus 1 seconds. So if I had to write the equation, S1 will be 0 plus half A P minus 1 whole square. Therefore, S1 will be A by 2 into P square plus 1 minus 2P. That is what S1 will be. If you talk about S2, with the same acceleration, S2 is the displacement in P seconds. So P seconds will be somewhere here, slightly ahead. So that is P seconds. So using S is ut plus half at square, u is 0 plus half into a into P square. So therefore S2 will be just a by 2 into P square. Fair enough. Now if you again start from rest at t is equal to 0 and now you move S1 plus S2 amount, question is how much time will this be for the same acceleration? Okay, again using S is ut plus half at square, S1 plus S2 will be ut, u is 0, plus half into a into t square. S1 plus S2 we can directly get it from here. S1 plus S2 we can directly obtain it from here. So let's see. S1 is basically this whole thing. So it will be a by 2 into p square plus 1 minus 2p, whereas S2 is ap square by 2. S2 is nothing but ap square by 2. So this is equal to a by 2 into t square. What you see interestingly is that this this particular a, 2, 2, a and 2 just gets cancelled everywhere. So I'm just left with p square plus 1 minus 2p plus p square is nothing but t square. Therefore, t square will be p square plus p square is 2p square minus 2p plus 1. Therefore, t will be the root of this thing, which will be 2p square minus 2p plus 1. Perfect. That is answer D. Very nice. So, initially, it feels like a scary problem that, sir, what is this p seconds, p minus 1 seconds? But actually, when you start solving it, it becomes very, very straightforward. I hope you saw that. Okay, it becomes very, very straightforward, my dear audience. Okay, so it was just that if in this displacement this much time, for this displacement this much time, for this total displacement how much time will you take? All the 3 times you have used S is ut plus half at square, nothing more, nothing less. Moving on to the next question, position of an ant in the YZ plane is given in terms of j cap and k cap. The magnitude and the direction of the velocity at t is equal to basically 1 seconds is asked to you. Okay, so let's try to think. Displacement is given, velocity can be found by derivative. So velocity vector will be ds vector divided by dt. So it will be 2 into derivative of t square with respect to time in j cap plus derivative of that constant phi with respect to time in k cap. What happens is derivative of t square is nothing but 2t. So that is j cap, and constant's derivative is 0. So 0 k cap. So hence it will be Hence it will be 4t j cap. That's all. So the velocity is definitely along y-axis. The velocity is along y-axis because of the j cap. That's it. And how much is the magnitude at 1 second? So velocity at 1 second will be 4 into 1 j cap, which is 4 j cap meters per second. Hence the answer is 4 meters per second in the y direction, not in the x direction, in the y direction because of the j cap component. Nothing more, nothing less. Right? What an interesting question. Moving on. Oh, we have reached the numerical part. So all these questions will be integer type, numerical type, which you know is again the second section of your JEE Mains. Okay. So let's have a look at it. A body of certain mass is thrown horizontally with some speed from the top of a tower, height h, touches the ground 100 meters from the foot. The body of mass 2m is thrown with another speed from a new tower, height 4h. Where will it land? Okay. Now, in general, it so happens that if you are on a tower of height h, and you throw any object with certain speed, it will land somewhere. That range formula is u into t, where time is given by root of 2h by g. That range in this case is given to be 100 meters. Fair enough. This is the general formula which you should know for horizontal projectile over a hill. Now, first of all, you should realize that this mass has no role to play over here. It is chumma given to confuse you because gravity is independent. Gravity is independent of the mass. Gravity is independent of the mass. So completely ignore this part. Completely ignore this part. So let's think about the next scenario. The next scenario is where the height is basically 4h. Now, where will it land if I throw it with the speed of u by 2? If I throw it with the speed of u by 2, what will that new range be? It will be that new speed into that root of 2h by g. H over here is nothing but 4h. Okay. So root of 4 is 2. So 2 comes outside and I'll be left with root of 2h by g. 2 cancels. It will just become u root 2h divided by g. What is interesting is it is the same number which I've got over here, which is equal to 100. So this number will also be 100. That means the new range is also 100. So answer is 100 meters. That was just by coincidence we got it 100 meters because of the values which were given, mentioned in the question. It's not like, sir, every time the answer will be 100, sir. Will it be same, sir? No. Here, the speed was halved and the height was quadrupled. Because the height was inside the root of 4 being 2 cancels out here. So hence the range came out to be the same. Otherwise, there was no reason or incentive for the range to be the same. I hope this is absolutely clear. Okay, moving on to the next question. Particle is going in a straight line, so the displacement at any time is given by x square is equal to 1 plus t square. Its acceleration at any time is x raised to which power? Interesting thing to note, x square is 1 plus t square. One option is you can write x is equal to root of 1 plus t square, then you find dx by dt, then you find d square x by dt square, which is basically acceleration. This is one way, but since it is root and then it is a function of a function, the derivative will look little complex. Although you might be fond of derivatives, I am also fond of derivatives, but I feel that there can be an easier approach to solve the question. How about differentiating this equation on both sides with respect to time? So it will become dx square by dt is equal to derivative of 1 with respect to time plus derivative of t square with respect to time. This will become, I cannot differentiate it with respect to time, so I'll use chain rule. So dx square by dx into dx by dt, derivative of a constant is 0 and derivative of t square is basically 2t. So derivative of x square is basically 2x into dx by dt is velocity is nothing but 2t. 2 cancels, so x into v is basically t. Wow, what an interesting thing we got. But I cannot stop there because I want to go to acceleration, so differentiate this further. So derivative of x into v is derivative of time with respect to time, differentiating this on time, both sides. This is UV rule, if you realized it. So it is x dv by dt plus v dx by dt. dt by dt is 1, okay? Now dv by dt is nothing but acceleration and dx by dt is velocity, perfect. So therefore xa is equal to 1 minus v square. V square, is it? Okay. And therefore, acceleration is 1 minus v square divided by x. Now, can I do something with v? Yes. Look over here. Look over here. Velocity is time by x. Velocity is time by x. Interesting. So, substitute that over here. So 1 minus, instead of velocity, put it as time by x. So it will be t square by x square by x. So therefore, acceleration will be x square minus t square divided by x square into x. Now what is x square? X square is 1 plus t square given in the question itself. X square is 1 plus t square, which is already given in the question, minus t square. X square into x is x cube. T square cancels, so it will be 1 by x raised to 3, which is x raised to minus 3. So acceleration is x raised to minus 3. So n value will be 3. N value will be 3. Yes, perfect. What an amazing question. The best part is we use chain rule. We did not find the root of or the derivative of the root of 1 plus t square, which would have been slightly more complex looking. We avoided that complication because of the knowledge of chain rule, and we know dx by dt is v, dv by dt is a. So it became little bit simple. So whenever you see an implicit, this is not an like a x is a simple function of time. When you see some complicated function is there, then what you do is basically use chain rule. Most of the times that will be the easier method. That's what even I have seen. Okay, the maximum height by projectile is 64. The initial velocity is half. The new maximum height of the projectile. I feel this question is directly based on the formula, nothing more. Okay, the maximum height formula for a projectile is u square sine square theta divided by 2g, and this maximum height is 64 meters. Okay, so if I just write h1 by h2, it will be u1 by u2 whole square, because theta is same, g is same, 2 is a constant. Only the speed is half. So height 1 was 64, height 2 I do not know. u1 is u, the new speed is u by 2, it is u by 2. So square it. So what do I get? 64 divided by h2, this uu cancels, 2 goes on the top, it will become 2 square. So h2 will be 64 by 2 square, which is 4, which is nothing but 16 meters. So the new height should be 16 meters, and that is the correct answer. Perfect. Awesome. Okay, just had to use the formula, and we saw that height was directly proportional to square of the speed, not changing the theta, not changing the g, nor that constant which is the number 2. Is that right? Cool. Let's move ahead to the next question. Wow, again some question on displacement in the n second. Yes, if Sn is the distance moved in the previous 1 second, and Sn minus 1 will be the previous second. So n minus 2 to n minus 1 kind of makes sense. What is the ratio of these two? For n is equal to 10, what is the value of that x? Okay, let's try to solve this question. First of all, if I write what is Sn, Sn is u, okay, starting from rest, plus a by 2 into 2n minus 1, because it is clearly mentioned starting from rest. So Sn is 0 plus a by 2, and what is the value of n? It is 10. So 2 into 10 minus 1. Therefore Sn will be nothing but 2 into 10, 20. So it will be 19 times a by 2. 19 times a by 2. Now let's do the second part of the problem. The previous second. So Sn minus 1. So Sn minus 1 will be u plus a by 2, a by 2. So n minus 1 means it will be 9th second. So 2 into 9 minus 1. Understand that? N minus 1 means instead of 10th second, it will be the 9th second. That's all. So Sn minus 1 will be 9 to the 18, 18 minus 1 is 17. So 17a by 2. Now you just need to take the ratio of these two. So Sn minus 1 by Sn will be 17a by 2 divided by 19a divided by 2, which will be 17 by 19. But we have to write it in this form, 1 minus 2 by x. Okay. How about writing this as 19 minus 17 by 19? Oh, sorry, 19 minus 2 by 19. Makes sense. 17 is 19 minus 2. So I can write it like that. So this will then become 1 minus 2 by 19. So now if you compare both of them, you can clearly see that this number 19 is just like this number x over here. So the value of x that we get should be the number 19. Yes, the value of x is the number 19. Very simple problem. You just had to substitute. Whenever these nth question comes, often people get confused that, sir, I think it is going to be some number series or that n minus 1. Sir, I get confused between the variables. So take your time, approach the problem slowly, you will get the answer. The best part was the value of n was given to us. If it was generic, then the answer would come in terms of n. So, that also is not there. It is actually very straightforward because the value of n is also given to us. Okay, moving on to the next question, guys, coming up on your screen. A bus is moving along a straight highway, brought to a halt, applying the brakes, the distance traveled using, this is straightforward, I believe. A bus is going with some speed. How much? 72 kilometers per hour is 20 meters per second. It will stop after some distance s over here. And how much time does it take to stop? It is 4 seconds. 4 seconds. So I think we can use s is nothing but ut plus half at square. S is u is basically 20 into the time, which is 4, plus half into the distance traveled by the bus during this time. Okay, now the acceleration is not mentioned. So can we find the acceleration? The answer is yes. Acceleration is final and initial velocity you subtracted. Final is 0. Initial is 20 divided by the time. Time is how much? 4. So it will be minus 5 meters per second square. So your acceleration will be substituted as minus 5 and the time value was 4. Okay, so 20 into 4 is basically 80 minus 4 square is 16. 16 by 2 is nothing but 8. 8 5s are 40. So hence the answer should be 40 meters. Let's check it out. Yes, the answer is 40 meters. Perfect. We got the answer. So acceleration was not given, but we could find it out easily by, the acceleration's definition, which is change in the velocity divided by the time. Final minus initial divided by the time. So very straightforward. Moving on to the next one. A particle is at rest, starts moving from reference point x equals to 0 along x-axis with velocity v that varies as 4 root x, the acceleration of the particle. Here velocity is a function of x and we have to find the acceleration of the particle. I have a feeling there is no need of derivatives. A lot of people might be thinking, sir, there is some derivative involved, integration involved. I have an idea. How about squaring this? V square is 4 square into x. So V square will be 16x. Now I'll do one thing. I'll write it like this. V square is 0 square plus 2 into 8 into x. Why did I write it down like that? Mathematics wise, there is no difference whether I write v as root x into 4 or v square is 0 square plus 2 into 8 into x. It's one and the same thing mathematically. The reason why I did it is because I can compare it with v square is u square plus 2 into a into x. Clearly from this you can see acceleration is 8. You don't even have to do anything in this problem. Acceleration is 8. See, in the solution, they have done it using derivatives, but I didn't even use derivatives. Now, how did it click me is because I have solved many problems and I know that whenever velocity is proportional to root x, I can square it and I will see v square will be proportional to x, which is like your third kinematic equation. So that's how I know it because of practice. So you too, when you practice enough or because you are seeing this session, it will be helpful for you in some other problem. Okay, so this is a very cool trick. I hope you understood it. Particle is going in one dimension. The variation of position is given as minus 3t cube plus 18t square plus 16t. Velocity when acceleration becomes 0. That is the question. What is the velocity when acceleration itself becomes 0? So maybe we'll have to go by standard method, nothing else. Velocity will be dx by dt. So take the derivative of this. So it will be minus 3 into 3t square plus 18 into t square's derivative is 2t plus 16t's derivative is 16 multiplied by 1. Therefore, velocity will be minus 9t square plus 36t plus 16. Now let's go to acceleration, which is derivative of velocity. This will be minus 9 into 2t plus 36 into 1. 16 is a constant, derivative is 0. So acceleration will be minus 18t plus 36, I believe. The velocity when acceleration becomes 0. So again, remember a similar question was asked again in this year only. Acceleration was 0. What is the velocity? So just find it out. So minus 18t plus 36 is 0. Or rather 36 is 18t. So t is basically 2 seconds. Now use that 2 seconds over here. So at 2 seconds, what is the velocity? So minus 9 into 2 square plus 36 multiplied by 2 plus 16. Just substitute, find the answer. You should get the answer as 52 meters per second. Exactly the same thing. Minus 3, okay, into this thing. So you have to find that out. All right. I hope this is absolutely very clear. This is exactly the same thing which we have done. We found it out. It is at t is equal to 2 seconds. Cool. Shall we go ahead to the next question, my dear students? Shall we go ahead to the next question coming up on your screen? Here it is. The displacement and the increase of the velocity for a particle in t to t plus 1 is 125 and 50. What is the distance traveled in t plus 2th second? Oh, interesting. So, from t is equal to t to t is equal to t plus 1, the change of the velocity is 50. That means if it was u over here, then, or let's say it was v over here it is how much? It is v plus 50. So for this particular interval, if you ask me how much is the acceleration, which is change in velocity upon the time, the change is basically 50 and the time is exactly 1 second. So it is 50 meters per second square. Wow, directly we got the acceleration. Can we find this velocity as well? Maybe it will help me for solving the next part of the question. Yes, maybe. Yeah. So can I find this velocity? Yep. Think about it. Maybe I can use s is ut plus half at square. So if I use s is equal to ut plus half at square, s is nothing but 125. U is basically v. Time is 1 second, sorry. Plus half into acceleration is 50 into 1 square. So 125 is equal to v plus 25. So v will be 100 meters per second. Interesting. We got it till here. Now the question is the distance traveled by the particle in the t plus 2th second. How do you do this now? How do you do this now? Guys, if you make this as t is equal to 0, this will be t is equal to 1. T plus 2 will be here. So this will be t is equal to 2 seconds. But in that old time scale, this will be t is equal to t plus 2. in that old time scale, t is equal to 0 will be somewhere here. I've changed my reference system and made this as t is equal to 0. So this will be t is equal to 1 and this will be t is equal to 2 in that new reference system. So the t plus 2th second here will be the second second. So using displacement in nth second formula. So displacement in the second will be u, all right, will be v in this case, which is 100, plus acceleration, which is 50, and the time will be 2 minus 1. So this is 100 plus 50 by 2 is 25. 2 2s are 4. 4 minus 1 is nothing but 3. So 25 3s are 75. 75 plus 100 is 175 meters. So the answer should be 175. Yes, it is 175 meters. What an interesting question, right? Great. So we saw that this is again based on multiple kinematic equations and the displacement in the nth second formula again and again. So this formula is coming repeatedly. You can see that. There is a ball which rolls off the top of a stairway, horizontal speed. Steps are 0.1 meter high, 0.1 meter wide. The minimum velocity with which the ball hits the step number 5 of the stairway is root of x. What is that particular value of x? That is the question. Now in this question, by the way, this type of question is also there in 𝑬𝒙𝒑𝒂𝒏𝒅𝒊𝒔𝒆. You should draw the diagram first. So this is the 0th step, this is the first step, this is the second step, this is the third step, this is the fourth step, and this is our fifth step, and this continues. If it has to hit the fifth step, meaning this ball which is rolling with what speed? U, it has to probably just cross that step 4 so that it will hit step 5. It has to just cross the tip of the edge of the step number 4, then it can hit the step number 5. That is the crux of the problem. Now if you ask me, where is this point located? Well, I'll tell you very simply. Just go from here to here and then go down here to here. You will see each step is 0.1 meter wide and high. So this total distance will be 0.1 multiplied by 4, which is 0.4 meters. And this is 0.1, 0.1, 0.1, like that, 1, 2, 3, 4, 4 times. So it will be 0.1 multiplied by 4, which is 0.4 meters depth. So now this is like a projectile from a hill of height 0.4 meters and the range is 0.4 meters. It's exactly that. So the question is find that speed. We know the formula for the range is u into root of 2h divided by g. The range is 0.4, u is unknown, the height is 0.4, g is basically 10. Okay, that's all you can see. So basically this will nothing but be, okay, let's do one thing. 0.4, I can just write it as 4 divided by 10, and this is nothing but u. And over here 2 into 0.4 is 0.8. 0.8 divided by 10, 0.8 divided by 10, I can write it as 8 divided by 100. Now root of 100 is basically 10, so it will become root 8, which is nothing but 2 root 2 divided by 10 over here. This is 4 and this is 10. 10 cancels, 2 and 2 also cancels, so I am left with 2 is equal to u root of 2. So what will u be equal to? 2 and root 2 cancels, it will just become root 2. So root 2, that means x will be number 2. That is the answer. So u value is basically 2. So we have used projectile from a hill formula. This looks like a hill. This is the foot of that hill and the base, the ground. You're throwing that projectile horizontally, it is falling here. So I converted it into that formula. All right. Perfect. Moving to the next question, there are 2 points separated by 80 meters in 2 seconds. The upper point's distance from the original starting point. So it is not starting from point A is what you can see clearly over here. It is not starting from that particular point. So let us draw the scenario first. Let's say this is point A and this is nothing but 80 meters and this is nothing but point B, and this has taken totally 2 seconds. So maybe it already has some velocity over here, and this h is what I do not know, where I have dropped it from. This is something which I do not know from the starting point. Okay. Displacement, time, acceleration known. So S is ut plus half at square, I believe. So let's use that for this particular location. S is ut plus half at square. Displacement is at. Initial velocity for point A is basically v. Understand that. Time is basically 2 seconds plus half into gravitational acceleration 10, time is 2. So from this, at is equal to 2 times of v plus 2 cancels, 2 into 10 is 20. So therefore, taking 20 on the other side, 60 is equal to 2v. Therefore, v is basically 30. So we found what the velocity is over there. But that is not the question. The question is, what is this height? So from here to here, why not use v square is u square plus 2as. Final velocity is 30. Initial velocity dropping, so 0. Acceleration is 10. Displacement is h. So 900 is equal to 20h. 0, 0 cancels. So it will be 90 by 2. So h is nothing but 45 meters. 45 meters is the correct answer. Okay. So you have to use one equation here and another equation for the upper part. That's how you get the correct answer. Cool. Let's go to the next question, guys, coming up on your screen. Okay, so there is a particle which starts from the origin with a velocity of 5 I cap, moves in xy plane under the action of some force. Some acceleration is also there. The x coordinate is 84. Then what is the speed at this time? If it is root alpha, what is the value of alpha? Read the question again. It's a two-dimensional question. It is going in 2 dimensions. Okay. It starts from the origin with some acceleration. So maybe it is going like this, and it will have two kinds of velocities. One velocity will be horizontal and the another velocity will be in the vertical direction. So combining both of them only, I will get the total velocity and the total speed. Okay, so I think we should treat x and y separately. It is clearly mentioned the x coordinate is 84 meters. So just look at that x coordinate at that time is 84 meters. So if I use displacement in the x direction is initial velocity in the x direction into t plus half into ax into t square. 84 will be starts from this with a velocity of 5 I cap. 5 I cap means initial velocity was horizontal and it was 5 meters per second. So hence I can just say ux is basically 5, time I do not know, plus half into acceleration. Acceleration in the horizontal direction is basically 3 multiplied by t square. This is an equation which I am getting, right? This is an equation which I am getting. But do I need this equation is the question. Well, I can find time from this and then I can substitute that time in some other equation. That's one way. Or alternatively, how about Vx square is ux square plus 2ax into sx without finding time. That will be much better, I feel. Yep. So Vx square is ux. Ux is basically 5 plus 2 into acceleration in the x direction is 3. Displacement is basically 84. So find how much is Vx square. From that, find how much is Vx. So it will be 25 plus 6 multiplied by 84. Come on, guys. How much is 6 multiplied by 84 plus that 25? Okay. Isn't it 529? This whole thing is coming out to be 529, and root of 529, my dear warriors, root of 529, my dear warriors, what is it? It is nothing but 23. Wow. So this is a perfect square which is coming when you do the math. So Vx is 23 meters per second. So I found Vx. Now the only thing left is finding Vy. The only thing left is basically to find the value of Vy. So how do you find the value of Vy? Well, I have an idea. Instead of doing this, how about now doing Vx is Ux plus Ax into t. Vx is 23, Ux is 5, acceleration is 3 multiplied by time. 23 minus 5 is 18 is equal to 3t. So t is basically 6 seconds. Wow, interesting. So we got the time. So now Vy will be Uy plus Ay into t. Initially there was no y velocity. Acceleration in the y direction is 2. Time is basically 6. 6 2s are basically 12. So 12 meters per second. 12 meters per second, guys. Are you able to see that? Very good. So finally, the total speed will be root of this 12 square plus this 23 square, which comes out to be as 673. Root of 673. Okay, root of 673. That is the answer. So the speed is root of 673. So alpha will be 673. That is the answer. 673. So we have avoided some quadratic equations here by using the third kinematic equation. And from this velocity, I found the time. That time we found what is the vertical component. Combining both the components, I get the resultant speed. That's all. Awesome. Moving on to the next question. A projectile is fired at 30 degrees and it is observed to be at the same height at 3 seconds and 5 seconds during the flight. What is the speed of the projectile? Okay, let's analyze this. This is the ground level. It is at the same level. It is at the same level at 3 seconds and 5 seconds. So this is t is equal to 3. So t is equal to 3. Probably I can write it like this. Just the journey time from here to here, it takes 3 seconds. And it takes 5 seconds to again reach the same height. So this is 5 seconds. So remember, this is to just reach the same height. That's all. This is just to reach the same height. Okay, now by the knowledge of symmetry, I know that if it takes 3 seconds to go up, it will also take 3 seconds to come down over here. It will also take 3 seconds to come down from the same level to this point. So this is also 3 seconds. From here to here, it takes 5. From here to here, it takes 3. So naturally, for the entire journey, which is made of that blue part, which is 5 seconds, and that green part, which is basically 3 seconds, the total journey time, won't it be 8 seconds, guys? Won't it be basically 8 seconds, guys? Is that right? Oh, so now I think I know the answer. The time of flight is 8 seconds. The formula is 2u sine theta. How much is it? 30 divided by g is basically 8. So 2 into u into sine 30 is 1 by 2. G is basically 10, is basically 8. 2 cancel. So u is basically 10 multiplied by 8. So u is 80 meters per second. So u is 80 meters per second. What a brilliant way to solve it. I hope you saw the trick. I have used symmetry. If it takes some time to go up from here to here, to go down also from the same height to here will be the same time. Now, this complements the remaining part of 5 seconds for the entire projectile motion. From here to here was 5, here to here was 3. So the total time would be 8, which becomes the time of flight. Using the formula, we get the speed. What a lovely question. Now, whatever we solved today was 2024 questions. Now, if you want 2022 and 2023, which again has good collection of questions, and for JEE aspirants, the best thing that you have is so many shifts, so many attempts, so many year papers, which gives you the right sense of the pattern, the difficulty, and the kind of questions which are asked. You also get to know which subtopics they are more inclined, what is the nature of the questions, how much time are you taking to solve these questions. That is the true test of your concepts. and the strength and the deep understanding of the subject. So I am giving you all these books of 2022 and 2023, all the papers, all the questions, topic wise and also section wise they have been arranged. None of the questions have been missed, as well as their solutions are given in detail for all the three subjects. So all the questions, detailed solutions, all the mains papers, every chapter has been organized with sections, so you can choose your chapter, your section which you want to solve. And all these material is available on the Vedantu store. Now the link is there in the description box. You can buy the entire paper, entire book set over here. You can just see JEE Mains chapter wise PYQs 11th and 12th. Just click on this link. You can see the Amazon link is also there, or even the store link is also there. So make sure you use this link to buy these books of 2022 and 2023. 2024 series, we are doing it right over here on the channel. Okay. So after this session, make sure you are writing kinematics PYQs done. Kinematics PYQs done. Okay. And the remaining chapters are coming in the days to come. Okay. God bless you all. Take care. This was Captain Shreyas signing off. Thank you for liking and thank you for tuning in by subscribing. Thank you so much. Take care. Hasta la vista.